Good morning, my dear students. Now we will move on to the formulation of LPP problems. Okay, so this is model one. Today we will solve the some formulation problem. Okay, so before starting, let me understand what is the general formulation of LPP. Okay, so in the given question, they may give you either maximum or minimum equation like this: Z of is equal to Cx1, C1 x1 plus C2 x2 plus dash dash up to Cn xn. So where C means constant value, x means variable. Okay, so subject to a constant, and that equation they will be give some constant. Okay, now so like that A11 x1 plus A12 x2 plus dash dash up to n number of equal variable, that should be either less than equal to or greater than equal to, that is some constant value, that is b1. Okay, like this they will give number of equation, and where and some restriction condition also they will give, like x1 is greater than equal to 0, and x2 greater than equal to 0 up they will give like this. Okay, so where xj is equal to decision variable and bi is equal to constraint levels, and cj is equal to objective function coefficient, and a is equal to constraint coefficient. Okay, so we will start the problem. If you solve one problem means we will understand this. Okay, so in first example they given like this. So cycle trends is introducing a two new lightweight bicycle frames, and the deluxe at the professional to be made from aluminum and steel alloys. So here the cycle trends is introducing a two new lightweight bicycle frames. We have two bicycles and lightweight frames. So the deluxe and the professional, they are cycles are professional and to be made from aluminum and steel alloy. Okay, the anticipated unit profit are around $10 for the deluxe, and $15 for the professional. Okay, the number of pounds of each alloy needed per frame is summarized on the next slide. What are the details in the given in the next slide? A supplier delivers 100 pounds of the aluminum alloy and 80 pounds of the steel alloy weekly. So weekly they are sending 100 pounds and 80 pounds. How many deluxe professional frames should the cycle trends to produce each week? They are asking that question. So first you read the question carefully, what they given, that you have to write here. The how many sections are there, how many materials are there, how many professional are there? There are two, that is deluxe and professional, and two materials will be there, aluminum alloy and steel alloy. Okay, so deluxe for aluminum is 2 and steel alloy is 3 and professional is 4, and to write the systematic manner. Okay, so later you write, and this is belongs to the maximization. Okay, now in the question they are asking what is the maximum profit per weekly. So here the main objective is maximization total week profit, that. Okay, now, and let us consider the decision variable x1 is equal to number of deluxe frames produced weekly, and x2 is number of professional frames produced weekly. Okay, so maximization is equal to what? Z of is equal to, just to add this number. Okay, so given in the equation problem only 10x1 plus 15x2. Why we are added here? It is a maximization, that is profit problem, so you add it. That is maximum of z is equal to 10x1 plus 15x2, and subject to a constant of 2x1 plus 4x2 is equal to 100 they given. So just here you 2x1 plus 3x1, you add it here, these three equation. Okay, 2x1 plus 3x2 and 4x1 plus 2x2 less than equal to, that question you write 100 and 80. So where the non-restriction values is x1 and x2 should be always greater than equal to 0. So this is about the solution. If you wrote only this much, you will get around 6 to 7 marks. Okay, na? So question is very lengthy in this section problem. So solution is like this, you have to formulate the questions. Okay, second problem is, we will solve the second problem. Here a second problem is given: a firm manufacture three products A, B and C. The profit are rupees 3 and 2 rupees and 4 rupees respectively. Okay, now the firm has two machines, and below is the required processing time in a minutes for each machine on each product they given. So machine and product. So machine G and H have 200 and 250 machine minutes respectively. The firm must manufacture 100 of A's and 200 rupees of B's and 50 rupees of C's, but not more than 150 A, and set up in a linear program to the maximization profit. So this is also a maximization profit is given. They given table also in the question. For the formulation problem they given question table, means it is very easy to solve. Okay, so what is the main objective of this? To maximize the profit. What are the decision variable? Here there are three columns, three values are there, A, B, C. Let us assume decision variable x1, x2, x3. Okay, A, B, C, that is x1 is equal to number of product of type A and number of product type B, and x3 is equal to number of product type C. Okay, so here the maximization problem they given 3x1 plus 3x2 plus 4x3. Okay, that is equal to maximum of 3x1 plus 2x2 plus 4x3, that you have to write. Here they given 4x1 plus 3x1 plus 5x2, 2x1 plus 2x2 plus 4x2 here they given just you write, just go and add it, okay, now less than equal to 2000 and less than equal to 200, and where that variation is they given in the year, so 100, 200 and 15, but not more than 150. So that is the condition they given right here. 100 less than equal to x1 and less than equal to 150, and second is given more than 200, okay, now that x2 is equal to greater than 200, x3 is equal to greater than equal to 50. So that we have to write the solution. So this is solution is very important, only 2 lines, but question is lengthy, okay. So we will have another third problem, okay. Third problem given like this. The Surset concrete company produces a concrete to ingredient in concrete or sand, that is $6 and the gravel cost of $8 per ton, okay. Sand and gravel together must make up exactly 75% of the weight of the concrete, and also no more than 40% of the concrete can be sand, and the least of 30% of the concrete can be gravel, okay. So the each day 2000 rupees tons of the concrete are produced. To minimize the cost, how many tons of the gravel and sand should be purchased each day? So this problem belongs to minimization problem, so you have to read the question carefully, okay. So here to minimize the cost, so if you minimize the cost, what about the profit they are asking? So decision variable here, the minimization the daily cost, so that is the main objective of this problem. And decision variable again here have the two sections, that is sand purchase and gravel purchase, okay. Decision variable x1 and x2 for the tons of sand purchase, and x2 is equal to tons of gravel purchase, okay. So again here the problem is given minimization, so z of is equal to 6x1 plus 8x2, okay, subject to a constraint of, just here nothing is given the value, just you add x1 plus x2 is equal to 1500, where x1 is less than equal to 800 and x2 is greater than equal to 600 higher, and where subject non restriction values are x1 and x2 should be greater than equal to 0. So here I given x1 is equal to less than 800 because you read the question carefully here, okay. Here they given also non more than 40% of the concrete, and the sand at least 30% of the concrete of the gravel, so they given less than, okay na, and each 2000 rupees. Again here the in the top they given cost of 8 per ton, because that is equal to 800, let us assume, okay. One more is given 6 cost of 6 per ton, so that is 600, okay. For that we have to write on greater on lesser than sign, okay. In the question they given profit and minimization problem. So this is about the LPP problem solution. So here in this LPP problem solution, just to read the question carefully, whether first to identify the objective and decision variable, then substitute whether it is maximization and minimization. So answer is very simple, 2-3 line we will get, but question is more here, okay. So that is the main difference between that normal LPP, that is we are going to solve in the second model, and this is one is the first model, okay. So this is not graphical method, okay. So this is also very important, sometimes they may ask in examination. Question is very lengthy, just to read the question carefully from this section, okay. I hope you understand these three problem. Thank you.